Hello everyone, my name is Suman from Uplatz. So the sessions we are discussing about previously SQL data frames, and we have been gone through various kind of data manipulations, data analysis with PySpark. Additionally, SQL knowledge. That's we added. That's we learned. But when it comes to data visualizations like graphically display, that's we learned matplotlib. If you remember in Pandas we have been gone through matplotlib for data visualization. That's a package which is used in Pandas. Uh, Pandas is okay, matplotlib is fine. But where is Spark? I mean, Spark has no built-in charting API. I mean, charting API is there. Charting API is not there. But we have to understand. We can use matplotlib to create plots. Okay? But however, we have to proceed with some caution when we using them. Why? Because Spark is mainly designed for handling sorry massive amounts of data. Okay, so that cannot be fit into RAM or memory or something like that, okay, in a single host machine, because that's a cluster computing. We know it, like I explained, and the different nodes has to be distributed the computation along with parallel processing is takes place. Okay, so these are the things we should able to understand first. Okay, so while creating any sort of charts, okay, so like already we have been gone through plot library, which generally requires the data first imported into memory, and calculations, and something we want to move ahead with matplotlib. For example, I just to give it here. If you want to create a bar plot on top of top 10 values of one feature, one column from any data with billions of rows or something like that, or maybe hundreds or thousands of columns. Okay, so we might use Spark query to choose the top 10 values. Why? Because those are billions of rows and hundreds and thousands of columns. I mean features. But definitely we have to move forward. Okay. So that is positive to matplotlib. So in this later approach, Spark does the heavy lifting. So that's the internal mechanism we have to explain. It might be during user presentation or maybe explanation, or how do we make sure to provide visualizations in a large scale of data. So that's the things I want to explain today's session. Okay. So the plot function is described below. Carefully so created in this mainly basis. So here we can see, of course, in the sense we attempted here to generalize the some extent. Okay, so but it's not general, but however, so we can say in this way. So it offers a notion of what can and should be done, build a visualization path. So here we can see I'm importing NumPy and Pandas, right? And Matplotlib. That's we done in early cases, right? And PySpark, which is needed for initial, I mean, to find out. And here I'm is importing from PySpark SQL Spark session, right? So this is very simple. And I just want to create a Spark session here. So into my variable called Spark. Okay. Now what I want to do it here, I was just want to take one data set, I mean data frame called life expectancy. Okay. So life expectancy, I'll just show it here. Maybe it might be. You can see this is the table which contains life expectancy. So it's very simple public data only. So it will be available. So the country name is there, year is there, status is there, life expectancy is there, and adult mortality is there, and infant deaths is there, alcohol, and percentage expenditure, and goes on BMI, body mass index, and till schooling. Okay. So these are the mostly, I would say 22 columns. Along with, now we do have something like 2,900 change, rows are there. Now we can see it's very simple data, and some of the variables you clearly understood. So BMI generally was healthcare related, and each country. So here we can see where countries are there, like Afghanistan is there, and so many countries, A to Z we can say, all till Zimbabwe. Okay. Now years they have taken 2000 to 2015, almost 15 years. Okay. And status developing or developed countries. That's we know it already. Some of the countries are developing at stage, and some of the countries developed. We know. Life expectancy, like age in years. For example, if you take 89 years, which country? Let's look at here. So 89, 88. So France and Belgium, Germany, they do have better life expectancy till 89 years. But still, we can't say. So very low age stage, for example, 36, 39. I mean, mostly below 40, right? So below 40, some of the countries are there, Haiti and Sierra Leone. These are the countries, very lowest stage of life expectancy. And because of various reasons, we can't say, why they are, life expectancy till 36 years or 40 years. I mean, very low age, 40 means very young for life expectancy point of view. But, you know, we have to understand, I mean, this is original data, which providing with various surveys and various extraction of sources. Mhm. So this is adult mortality and goes on like this percentage and BMI, body mass index. Okay. So that is also important for, understand, and total expenditure, and some of the diseases are also there, HIV and AIDS, because those are severe diseases, we know it. So that is also we have to take in care of. And GDP. So GDP, of course, it's a financial, but we have to understand population and like that. Okay. So it's very simple. I mean, it's not very simple, I would say, but it's understandable data, like unlike, other domain or something. So now what we'll do it here, I'll just take up this data and just to show it here in our notebook. So when I go to my notebook, so here we can see first we are importing our packages, right? So let's import it here. Okay. And just go ahead with simply PySpark SQL Spark session and just create your Spark session. And in these cases, we can see I'm gone with Spark read dot option, and info schema I'm just giving true, and the data we are taking CSV file, because CSV, right? So after input schema, after options, we have to give a CSV file name, file type. Then we have to give it. So if it is contains header, already we know it header is there. So give it as a header equal to true. And if you want to show it any column, rows, then show it rows. So in these cases, we are getting into two rows. So we can able to see it here. These are the two rows. Country is there. Year is there. Status, life expectancy, mortality, and deaths, alcohol, and so many things like population and HIV/AIDS related and all those things. Okay. So this data point, let's move ahead with the tabular visualizations. So pandas were better, was better. I mean, we can convert Spark data frames to Pandas data frames. So that's we already discussed it. However, we just want to see the top view of converting the top rows of a Spark data frame to Pandas. Makes sense. Okay. So it reduces computer memory use and especially Spark DataFrames are often mainly designed to handle huge volumes of data, right? So here the same DF, whatever we created, I mean Spark. So here I'm giving limits file to Pandas. Okay. Now just look at here the data. So we can see we got just 0 to 4 and we got it to Pandas. It's converted. Okay. And if you want to look at the print schema, already we know it early. So print schema means it will show it the column names along with the data type and whether it is a nullable or not. Okay. So this is the information it's provide. Generally, print schema provide all this information. Like each column here we can see and column type. Now obviously country is a string, we know it. Year is integer because years are mostly 2000, 2015 we have taken, right? 15 years data. So integer kind of number. Status is string, okay? And life expectancy, like developed or developing and those things, strings. Life expectancy is a double because it's not integer. If you look at here, I mean here 0.0, 0.9 and double. It's nothing but double. The integer like that goes on. You can see, and these are the values. Now let's move ahead and make sure to understand this sort of data frame, what it provides. So generally, what is our goal is first, like we learned PySpark data frames and their operations and Spark SQL built-in functions, right? And selecting some data and some few data or few data, I mean columns. Okay, so that is the main, I mean section we can say to use a select method. Then manipulating data, like I explained, manipulating data and filtering and selection and Spark SQL strings. So these are the things we covered with various kind of arithmetic, mathematical, aggregated function, string related functions, date time, and all those stuff. Okay. Now, what we'll do it here, just we take up, I just want to explain here for especially visual perspective. Okay. Data visualization perspective. Now, let's move ahead here and we'll make sure to understand. Spark charting. Let's say we'll focus on first Spark charting. Okay. Like I explained here, Matplotlib is there and the Spark related is there. Okay. Let's discuss about Spark charting. Spark does not have built-in and which I explained. So we can use Matplotlib to create plots. So that is one thing. And this is just for pre-calculate data before, I mean, sending to Matplotlib in certain cases. Okay. To create any bar plot, but because plots are there, we know it. A bar plot is there, scatter plot is there, and something like histograms are there. There's so many things. Okay. So now we will do it in that way, and we'll make sure to understand. So here, in these cases, what I'm selecting just country, year, alcohol, and GDP and population. Right? You can see. So I'm just storing only few columns. Of course, you can take any columns. That's up to us. But in our cases, we have taken this country name and years. I mean, life expectancy years. I mean, year collected. It's not life expectancy, year collected, alcohol and related, uh, GDP and population. Okay. Now I just run it. Now it's stored and just look at the data here. Okay. These are the, I mean, 3 rows which I requested and we got the 3 rows with limited columns. So this already we have done in Pandas, if you remember. Okay. So in Pandas, what we'll do it? So just I will explain. DF is there, and we'll take LOC as square bracket. We will give it, comma we will get it, and the same columns you can take it like this. For example, here I would say. I think square bracket, close it, and put a colon. Okay, this is the pandas notation. I mean, I'll just give it here. So this is in general pandas notation, pandas kind of style of notation. Okay, and this is for Spark related because we have to give it a select method so that it can understand what columns this person is interested. So among total columns, so I just want to select these columns and just want to show that. Okay, now, so let's create one plot called histogram. Okay, so histogram is what? First, let's try to understand histogram. Histogram is nothing but the data which is gives in the distribution. Okay, so the data which will gives us a histogram. Okay, so in general, whenever we do have a couple of variable like one variable or couple of variables, but if I want to look at the data, how the data is distributed. For example, you can take any data. Some ages are there, but inside we will take it this histogram. Okay, so that itself, which I explained, like Spark does not have this built-in charting, right? So this means we should able to need to rely on, I mean, depend on external libraries like which I explained, Matplotlib. So this less memory and the same time, and also Spark histogram Matplotlib. Okay, so histogram will mainly focus on the data which is gives us distributing data. Of course, we will get lowest highest more sense. We will get a y-axis indicate like x-axis indicate the values, whereas y-axis indicate how the value is distributed from lowest to highest. I mean, is there any certain positions? There is a flatten. Is there? Is there any certain positions? The values are moving ahead, like overestimation. Like that, it will provide it. Okay, so that is the main goal of histogram. So what I want to do it here, I just want to create histogram, but I'm taking df data frame. I mean function we are creating here because we learn functions and columns, bins. That's up to us. Like in this case, I'm taking 10 and x name, y name also you can give it if you want to understand. But what I have taken here, so this function makes histogram from Spark data frame and name df column and column name is a column. Okay. So select I'm just giving a call and the RDD flat map, which we learned early, flat map to flat map related. So that is we are using for calculating histogram in Spark along with lambda and histogram bins. And we want to pre-process histogram points and locations, right? So width also I'm just giving. So values 0, 1 and this value and the location and in the same way LOC. But here I'm taking something like, list comprehension style. So range of length of total I have taken. And now let's make it a plot here. Okay. So I'm just giving plt.bar and LOC. And here we are giving values 1 and with the code x label okay and y label okay. That's we are giving and plt.show we are just giving. This is just for function. Now let's run it. Now function is created. Now the same function whatever we created, I'm just calling invoking. So I just want to take my invoking in the same df data frame because our variable we have taken and the similar way here also we have taken, but column I have taken GDP. I just want to look at my GDP related histogram. Like I explained, ages related, or maybe it might be marks related, or it might be prices related. Okay. So that is what single column, one thing. Second thing is it will explains the distributed data with various kind of bins. Okay. In this cases, I'm giving 15 bins, but you can change accordingly. And y name, we are giving number of countries. Obviously, this is number of countries, okay? Because the data is it's giving into values, okay? But in the left side, y-axis will provide the count. Count in the sense like GDP related counts, okay? Now let's look at here. So GDP related, countries are all these values, okay? So most of the countries less than 20,000, right? Obviously, very lowest. I mean, very lowest in the sense like, we can make sure to understand. But few of the countries are there, okay? Few of the countries are there, but, very less numbers. But most of the countries are here, you can see. That is what distribution. I mean, that's what the histogram or bar plot we can say. So it's giving very clear information. In the same way, so here we can see, I mean, the data is skewed. It's nothing but data is skewed in these cases. Okay. And we'll take it another variable called alcohol. Okay. Now we'll look at alcohol. What happened here? We got the data like this. Okay. So almost it's going in this way. Okay. It will be skewed to the left or right. Okay. So that is what difference. So what is this? I mean, graph it shows, whereas this graph shows here a lot of variables are there, like alcohol related, you can see. So some of the countries are even alcohol contains 12.5, 15 point, even further more. Okay. These are number of countries, but most of the countries are in between below 0.5 and nearby 2. You can see. So nearby 2, 2.5, there are 300 plus only 320 or some variables are there. Some, countries are there across total. So that is what distribution. So it's skewed. And in these cases, what do we understood and what do we got it from this, values? So we can able to look at the data and we can able to understand the data. And in meanwhile, we can also see how the distribution will be, help us to provide either GDP related or it might be, like related to one R variable called alcohol related. Okay. So this will be explained. This will explain, information in regarding distribution data along with a chart, I mean graphical display. That's important thing for us. Why? Because important thing for us. Why? Because the data we are looking not just like a numerical way, okay, but we are looking the data in a graphical manner, and we are also giving custom function. I mean, we are defined custom functions in this our data. Okay. So it's possible, I mean, we have to understand somebody has created any custom histogram, okay, function or something like that. So that will be utilized for generating histogram from this Spark data frame. For example, in my case, in our cases, we have taken maybe GDP, right? But the same concept he can work just changing the column name. Maybe you or maybe might be me or other person. They can use this function to provide, relevant with values. Okay, relevant with their values. Okay. Now in this case, what I have taken important thing. Okay. So first thing is we created one function which is histogram to generate histogram for GDP and alcohol. Same thing. Okay. And from what data frame? DF, which give it here. So what I want to do it here, I just want to break down this entire, I mean, code. So first is histogram, second thing is the data frame, third thing is the GDP and bins, right? So DF refers to what? Data frame, containing actually the data, which we know earlier. GDP, this specifies the column in the data frame, in our data frame, so that whatever we want to create histogram for, or histogram we want to use it. Then after we are using bins. So this is bins are nothing but intermediate, values. So in this cases, I'm giving 15. Okay. So bins are intervals, mostly we can say. Let's explain in clear way. Bins are nothing but intervals on the x-axis. So that generally groups the data values. Okay. So bins are nothing but intervals. So that will be for the x-axis, but that should be grouped the data, their values, data values in that way we can say. Next after y name, so y-axis name, it's a simple, very easy to understand. Whenever I am giving y name there, like number of countries, it's showing in the left side in the y-axis number of countries. To understand for the, of course, we are creating histogram, we know it, a number of countries, but other person who can, our whoever we are reporting, or maybe the story we want to build on top of it, so they might not familiar what is y-axis. So we have to write it down in a clear way. So that we are just writing number of countries. Okay. So that will be better to setting a label. It's nothing but label only. Y-axis is nothing but label. So the number of countries, right? Now, so we are giving this entire line. So that is a histogram till to parenthesis closer. Okay. So this lines generally appears to be it's doing like same as, alcohol is also same way. Like if I just move down, here, sorry, GDP and this alcohol. So both are same. Okay, same in the only thing is column name changes, column feature name changes. Okay, but whatever early we created, just we copy paste, nothing else. Just change the column name. Okay. So now we know it early. So like while the provided source, data. So don't explicitly, we can say mention the histogram function. It's like in the way like that the function is, we are using. Okay, so that's one thing. Now question comes to here is where Pandas DF comes into, differ compare with the Spark data frame, which I explained. Like first thing, of course, so we are creating, we can also create custom functions even Pandas. But there we do have plot methods are there. Hist kind equal history is there. If you remember, plot is there, kind equal history is also there. Okay. But here the function from library not mentioned in mainly, but we have to understand and consider based on the whatever Spark related charting. Okay. And pass charts kind of things. Okay. One thing is I would say memory limitations. So if our data frame is very large enough, so we need to careful about the using this plotting library with like matplotlib. So why? Because they are requiring loading all data, data points or data into memory. So the pre-processing and all this thing, but pandas converting subset to of our data frame and you just make it into histogram. Okay, so that is the difference. Now here we can see population same way, nothing else. So number of countries same way population, but here we can see the same data frame we are getting into population. Now you can see now population obviously so many populations in here by right. Okay, percentage wise we can see now. Okay, this is fine. We do understand a graphical manner. We gone through various chart of histograms. Okay, various chart of histogram. In the similar way, can we know it a summary of the data? Okay, summary. Summary is nothing but what? Like the data is there, but I just want to look at maybe a statistical summary. Okay, statistical summary. If you want to look at the statistical summary, then we can look at this statistical summary. So it will give information about any data like it will provide a simple, not only simple information, but statistical information. That's important. Count is means what? Total count. Okay, now population I am taking here. Can you give it me population and relevant of the population summary, and can you show it? Okay, population is one column. We know it. One column, select and give it a summary and show. Now what it's giving? First is it will give count. Means population, there are 2286 populations are there. It's not about I mean it's about values. How many values are there? 2286 total. Okay, total rows in that sense, in the general way. Second thing is average. So average population we got 1.275. Okay, so what it gives us, important thing is, so the average value of the population column is 1.27. Means what? What do we understand? Which is approximately 12.75 million. It's nothing but, we have to understand this is nothing but 12.75 million average. Okay, so whereas count the number of non-null values, it's not like, I would say this 2286 indicate. So I just want to create here one markdown to explain in a better way. So first, if you take it count, count function, sorry, count function, and which is what we have to understand. So this is nothing but the number of non-null values, okay, in the column as how much? Say here 2286. These are not null values. First thing, that is a count. And second thing, which I explains mean, sorry, mean. So from mean perspective of functions, so what do we understand from mean perspective? Like this is nothing but approximately 12.75, so million average, average or mean we can say. So this is what mean. Now standard deviations. So what is standard deviations, which I explains? Data, how the data values are vary. Of course, variance is there, but more specifically, we can take standard deviations. Okay. So which measures what? Mainly which measures spread. Okay, spread related to what is important. Okay, spread related to like of the data around the mean. You can say spread the how the which can measures or otherwise is the spread around the mean, we can say. That is important thing for us to understand. That is standard deviations. Okay. So which we got to what? 6.10, right? So almost 6.10. I think 6.10. So that is we got it here. Now next option we got it what? Now obviously minimum. This is very clear. And out of total population, what is the minimum value? Okay. So minimum value 34. You can see 34 we got it, right? So lowest population we got it here is a 34. Okay, population, I mean 34. So that is the minimum value. You can say simply minimum value from population. So that is 34, we can say. It's very simple. And the second concept, I mean third concept, I just want to explain 25% is there. Once I explain these things, you can easily understand 25% you can take, and just to make it a comma here. And second thing is what? 50% and 50%, sorry, 50%. And second thing is a 75%. So these are the three. Okay, these are the three. And these indicate what? I mean, just want to give it a new column. So for make sure to understand for you, just to give it a two spaces here. Now it goes to new column. The standard deviation, right? Ah, which will give first quartile or 25th percentile. This also called as 25th percentile, one option. And this is also called as first quartile. Either way, we can call it as first quartile. In a similar way, 50th percentile or second quartile. Okay, so that is also we can make sure to, I mean, in more specifically, we can say this is 50th percentile, one option. And the second option is better to understand. This is called median. It's not only just percentile, but it's also provide a median. And third thing indicate 75th percentile, right? So 75th percentile. Okay. So this also called as third quartile. Okay. So these are the information providing for us. Okay. So first quartile we got it something like I think first quartile what we got it 195553, right? So that is a population. I mean, whichever the population less than that value, they are fall under 25th percentile. Okay, 50th percentile. So we got almost 13,84,000, right? So that is 50th percentile. If that exceed, they can say they are better than 50%. Regarding population, it's not like overall. Regarding population only, they are better than 50%. Take it a simple example, like marks are there, student marks are there, you are taking a summary. But how can you say a particular person marks better than 25th percent of their batch, their students, or their co-students in that way? Okay? So a person who has maybe you can take this is maybe out of 200 or something like that. Okay, so a person who is getting into 19.5 and something like below, then I would say in the same batch of students, he is lower than 25th percentile. Why? Because he's, I mean, person who got 10, 12, or maybe lowest. If we assume 1019 in that way. So if you assume this is 138, even 50% better. Even if you assume 740, even for better 70% in that way. The maximum values already we know it, just like mean only. So copy paste here simply, and this provide a maximum value. So statistically we are looking maximum value and maximum value almost we got it into 1.2, right? 1.29, right? So it's nothing but 1.29 billions in the sense, because we are taking into population, right? So in the billions we can say. Okay. So what are the insights we got it from this simple summary? So the population column has these entries. I mean 22, I think 2286 entries are there. That's we understand first. Second thing is the average population is around 12.75 million. But the large standard deviation suggests, and we can be able to understand wide range of population values. Because standard deviation when is large, it's nothing but spreading more spread the data. So that indicates standard deviation. The minimum population is 34, indicates very small region country, region or entity. So let's look at here, 34 population, right? Let's look at that country here. Maldives. Obviously, those are ocean, these values, right? So those values contains very less population. We do understand, right? In the similar way, here we can look at even 36, 36, 41. Same, all this. They are collecting in different years. That's important. 2014, 2019, maybe slightly increased or decreased, maybe decreased. 2014, even year moving forward, it's slightly increasing. Okay. So let's make sure to understand in that way. So that is the values which we are getting. So the percentile shows us for distribution of population values. For example, 50th percentile of the entries, right? So here in our data, so 50th percentile of entries, what do we understood about 50th percentile? Like population less than 1.38 million, while 75% have population less than 7.42 million. Okay. So this is indicates for us, this indicate insights for us, high population that skew the average. Okay, in general, this. So this data particularly, large difference between the mean and median, one thing is, and high standard deviations, which generally suggest for us to skew the distribution of population values. Okay, so that is one thing. And second thing is there are very poor countries also there, so that we do understand for from this all this data we do understand clear information, right? So like that we'll move ahead. Now the same histogram I just want to filter, not I just want to take out, but I just want to filter some data, right? Population I'm taking, but I just want to filter some context less than, and in the same data I just want to provide here population and bins. Same way. Now let's look at. Now we got it here. Okay. So this data will indicate further information. Like here we can able to look at the data, and we can able to see it not just like numerical summaries, but in the graphical summaries also we are looking. But across total, instead of total, we are just looking into filter some context. Okay. Here df dot filter of df dot population less than indicate what? Only the rows where the population column has value less than that 100,000 and 1,000. In that way we can say. So that is one thing. Population. So this is an argument we can say, which generally specifies that histogram should be created using population column. Okay. Now bins already explained, why name I explained. So all these things information which clearly indicates. Okay. Now do we understand? We understand just one plot only, that is called histogram. Okay. And we do got to know it how this histogram will gives us a lot of insights. Additionally, we have been gone through summary as well. Okay. And summary as well as like graphical display. Now let's move ahead with the line plot. So what is line plot? Let's try to understand first line plot. So line plot always indicate lowest to highest. Okay. I mean, how mostly in line plot, it's provide information related to values, okay, related to values, but like in general, line plots are useful for in cricket, I would say. In cricket, where we want to look at a run rate. Whenever we want to look at a run rate and compare with other country, for example, two countries are there, they have some match. But suddenly, I want to know it how one country is playing with against with other country. Okay. So in that cases, I have to look at my run. I mean, our country run rate or other person country run rate with opponent country run rate, so that we can understand. Okay, this is the somewhere in this particular over a particular range of overs very less run rate, and in this particular over better run rate. Okay, maybe that you can give it one color line, and this maybe other country whatever next batting you can give it another color, so that you can compare while going 50 overs. Maybe let's consider the 50 overs like one day match. In general, one day match has 50 overs. Okay, now in this 50 overs, how the run rate is there? In that cases, not histogram is better, but line chart is better. So that's why I want to explain here. So histogram will, line chart will provide comparison, not only comparison, it itself is explains. So the information, like along with, how the values are changing accordingly. So that is indicates for us. Okay. So for this, what I have taken here, the main purpose is this function is mainly aims for us to visualize the relationship between two variables. Okay, in our Spark DataFrames. So, second thing is X indicate what the column name represents independent variables we are using, and Y indicate the column name same way dependent variable. Okay, so that we can plot in the Y axis. Measure indicate that determines the aggregations method. Okay, X related to Y. So the default is the mean actually. So if measure equal to mean something like this. So we are taking here we can see year wise we are looking. Year wise what we are looking is important. The dependent variable is GDP. So 2000 GDP is very less. You can see, okay, 2002 slightly similar. But if you look at 2004 and the gradual increase, 2066 or something, 7, it's very high GDP. Now suddenly gradually decreased 2008, because during that time, even I remember like the recession is there, 2018 banking sector and all those things. So that time definitely GDP will be less, mostly. Slightly again increased, slightly decreased, of course goes on. And since we are taking very almost 10 years back data, 2015, 2014 in the sense, 10 years back almost, because right now we are in 2024. Of course, very historical data we are taking, but the meaning we can understand, the important information we can understand. Okay. So that is information, but line chart will gives us, this is first important thing for us to understand. Line chart will gives us relationship between dependent versus independent variable. You can take dependent in the y-axis, independent you can take x-axis, and compare how these values are, make sure to change according to independent variable which host on which gives an x-axis. So that's what line chart. Okay. So here gives us information. Like here I'm taking average, right? So mean, group by, these are all things we discussed it. So I'm not going into that kind of thing, but at least you have to understand logic. So we are using mean, average. Okay. So if our measure is said to be mean, So the function groups the data by X column and calculates the average of the Y column for each group. So that's important. So the result is converted to Pandas data. So that's why we are using PD underscore DM. That is for plotting. Okay. Otherwise, else if we are using measure double equal to total. Here we can see total or something like this. Total you can see. Okay. LF we are giving. What this indicate? First indicate mean. Okay. In if condition, this is about mean and grouping data frame, and we are just looking forward for mean. Second option, we are looking count and related to measure and total. So this function calculates the each group defined by the X column. And second thing is measures count functions. So that will be indicate count related. Okay. So the next value comes into plotting. Of course, you can give it a Y label, and we are giving Y label GDP and X label a year. So like that goes on. So in the similar way, can I, once you create function, you can do it for any plot in the sense like, associated plot, whichever is compatible in that way. So here I have taken year versus GDP, right? Year x-axis, GDP y-axis. Measure I am giving me. Now, in the similar manner, here I am giving year, but population I want to look at. Now we can see year-wise population I can see. So 2000 population is 1.27 or something, 27 or 28. Now 2002 population is very low, like 1. Now suddenly 2004, it will be slightly increasing and decreasing and goes on. And 2014 is very highest population, almost we can say 3 billion in that way. Now in the similar way, alcohol also you can take it and better. So 2000, because of past year alcohol is very high compare with current, I mean 2014 years slightly like decreased. Okay. So these are the information gives us a lot of information regarding this value. Now in the similar manner, can I move ahead with the bar plot? Okay. So bar plot is already obviously I explained. So this information gives us a bar plot according to DF column. Here in the bins place, we have to give limitation, and we are creating, we are grouping, and we are showing. Now let's run it here, and then after create one plot. So we got it here. You can see 2013 and number of data per years highest, right? Now if you typically you can do these variables, these years, so almost nearby. Okay. So this is what plot. Okay. So here, every year we get almost the same. The only thing 2013. Okay. Now let's look at alcohol related same way, but we got it here 0.01 highly and slightly decreased. This is also skewed. Okay. So in the similar way, which country has the largest population, which country has the largest GDP, just move ahead. And in the similar way, pie plot also we can use it. So pie plot is better in the way of categorical data. If you want to look at percentage wise, like 100 percentage, how much this percentage. In that cases, pie plot is better. So for that, I'm creating one more function and I just want to look at country. So country I'm looking here. Okay, pie plot. Okay, we got it here. Let me run it all steps again. Internal server error. Is full. Okay. I think my related to disk related issue. So that's not a big deal. Tomorrow also we can able to run it because of memory. But I will explain this data. I hope you understood. This is only bar plot related, I mean pie chart. So pie chart we can say, pie plot we can say, but across total categorical data we can able to look at. Okay. So that is about and box plot. Finally box plot which will gives us whatever we learned summary. So that will provide a summary here. Okay. Or here you can look at, no problem. I think this, okay, this will be provide us, no problem. Now you can see what we got it here. Pie plot we are giving, data frame we are giving, country we are giving. Now, which country has highest in these cases? Okay. Now, Republic of Korea is there, and similarly, some of the countries are there. So these countries will give us information like highest. But if you look at alcohol 0.01, obviously most compare with not a number. Abhi, missing values are there. And year wise, if you look at also, you can look at year wise. Now box plot perspective, we can see box plot. Okay. So box plot grouped by year. But if you want to understand this box plot, it will be complicated for us as right now. But it can provide outliers. It can also provide statistical summary, which I explained earlier. So that's also important for us. Statistical summary and graph, which will provide us. For example, in these cases, we can see for this 2014, outliers are there here, almost 1.2 more. Okay, but here we can see the median along with first quartile, third quartile, and outliers. These are all things which will provide us for year wise. In a similar way, you can look at population, but we are just comparing, not taking into all the values, but we are segregating, comparing, only filtering couple of values, and we can able to look at the data as to. Okay. So that's about the data, and I hope you got it, understand. So this is about plotting or charting, or we can say graphical display to tell the story regarding uh, life expectancy. Okay, that is what I want. I mean, this is not just a simple session or course or something. This is just treat like a case study because we are taking one particular data, one particular real life data across 15 years, not just like 1 year or 2 years. So 2000 to 2015 years, taking the data across globe. It's not like just like one country or few countries. Across globe, we are taking a lot of countries, their data, their life expectancy along with GDP, yearly wise. Similar way, whatever I just explained, you can excel your skills. You can try for yourself with another variable. For example, BMI is there, body mass index. That we didn't use it here in our visualization, right? Now you can take up that kind of variable, that kind of feature, and you can apply these kind of information like either histogram, either pie chart, or maybe line chart or box plot. Okay, and maybe box plot. So these are regular graphs, not only just like early we learned in the pandas perspective, we do understand plots, and each plot separate perspective also we have been gone through. Like what is the line plot? Like line plot is provide information regarding highest, lowest, and decrement, increment. Whereas pie chart will provide total 100 percentage, how much this percentage. So that is a portion. And along with other variables, if you took it like histogram and bar plot, especially it will give bars. But in our cases, bar plot is not better. I mean, it's giving into same. In certain cases where counts are less, counts are more, counts are medium. In that cases, bar plots are makes better. Okay. Even box plot is also not good for as of now, but you can use box plot for any other data, but other variables. So here out of 22 variables, we are taking just few variables, few columns. Okay. I have taken GDP, I have taken year, I have taken life expectancy, and similar way we have take out country names and population, alcohol. These are we have taken, right? Now your goal is to extend your skills, extend your practice with other variables, like whatever variables if you are interested, like you can provide in that way, and you can create one like function, or maybe you can directly write it, or you can filter it certain context, and you can provide some charts. So that's a total I want to say. Okay. So that's about these sessions and today's, and I hope you got it, understand. So now I'll just want to wind up these sessions, and next session we'll discuss further things related to PySpark. Okay. So some of the things are left over still, and we just going to complete. Okay. So thank you very much, and thanks for watching all these sessions, and thanks a lot. Thank you.